This video is all about Blaise D. Vigenere's cipher. This is used in coding and coding ciphers. The basic terminology used in this video are the plain text, which is the original message, cipher text, which is the coded message, cipher, which is an algorithm for transforming plain text to cipher text, key, which is the information used in cipher known only to sender or receiver, encipher or encrypt, converting the plain text to cipher text, decipher or decrypt, recovering cipher text from plain text, cryptography, which is a study of encryption principles, methods, cryptanalysis, which is the code breaking, the study of principles, methods of deciphering cipher text without knowing key. The method 4 is Blaise D. Vigenere's cipher. There are two different versions. The first one is the auto key method or short seed, which is also known as primer. Usually it is a single letter or two letters. And in this video we are going to see examples for both single letter word and two letter encryptions and decryptions. The auto key method is used with the modular arithmetic mod 26 because all these alphabets are numbered from 0 to 25, so it is mod 26. Let's see this example of encoding the message to be or not to be using the priming key L. So let's enter all these letters in the message, to be or not to be, and the numbers corresponding to that are written in the third row. And in the second row, let us include the priming key as a prefix along with the message. So since L is included as a prefix for the message, the last letter E will be omitted. That will be dropped. And the numbers corresponding to the first original message is written in the third row. And since the seed S is the primary key L, the number corresponding to that is 11. So in the first column, if we see P1 is 19, S is 11. So we are going to add them together because we need P1 plus S as C1 and PK plus PK minus 1 is CK mod 26. So in the first case, I'm adding P1 and S, which is 30. Using modular arithmetic mod 26, I get the answer as 4. The same way for the second one, it is 14 and 19 added together. Let's see another example. The message is I like number theory. The primary key is Q. So we use the same table to convert that into numerals, and writing the message I like number theory and the second row with the primary key, then adding them together, the two numeral values, getting the modular arithmetic, I can get the encoded message for I like number theory. So here in this case, tomorrow is Friday, the primary key is T, the same table is used, and tomorrow is Friday. And again in the next row, we take T as a prefix along with the message. So the letter Y is omitted there, adding them together and taking them. The other example is from the textbook, say page 208. P1 plus S is congruent to C1 mod 26 and PK plus PK minus 1 is CK mod 26. The messages happy days are here, primary key Q. So using the same way, we can find the modular arithmetic for this, the total values, and that happens. Let's see another example. How fast the year did go? The seed is M. The primary key is M. So the letters can be numbered, and writing the message how fast the year did go along with the seed, writing the numerals, adding them together, finding the modular arithmetic, you can find the message for the encoded message for how fast the year did go. Let's do the reverse process now. The encoded message is given. This is received by the receiver, and he knows that the primary key is T. Now the person wants to decode it. That is, they want to get the plain text. So we know that this formula is used. P1 plus S is C1 mod 26. Pk plus Pk minus 1 is congruent to Ck mod 26 because I have only one key here, one letter word, key. So if from this, if I want to find the value for P1, P1 will be C1 minus S, and my Pk will be Ck minus Pk minus 1. So I have to use this new systems of congruency equations to solve, to get the values for P1 and Pk using the same numerical values. Let us write the encoded message first, and we know that the seed is T. So for the letter B, the number is 1, so that is your C1. And for the letter E, the number is 4, that is C2. So the third row here gives us the value for C1, C2, C3, etc. The third row gives us the value for C1, C2, C3, etc. Now the seed S is T, the seed is T here. So taking the numerical value as 19, subtracting 1 from the other, I get that as negative 18, which is my P1. So my C1 is 1. The number for S is 19. Subtracting 1 from the other, I get negative 18. Negative 18 is P1, but for the modular value, that is 8. Now this 8 should go under C2 because that is my P1. C2 minus P1 becomes my P2. So 4 minus 8 is negative 4. Negative 4 is the same as 22, and then 22 is my P2. So P2 goes under C3. 22 minus 22 is 0, so the value is 0 itself. 0 goes under the next letter, N, which is 13. 13 minus 0 is 13. So like that, if I continue, the last one will be 24 minus 25, which is negative 1, or using the modular arithmetic, that is positive 25. So when you convert this to the letters, the plain text message will be I want to Z. Let's do a problem from the textbook. The encoded message is given, but here the primary key is two-letter word RX. So the first two equations are using the seed. So P1 plus S will be C1, P2 plus S will be C2. And from the third letter onwards, it is Pk plus Pk minus 1 is congruent to Ck when k is greater than or equal to 3. So by converting it, my P1 will be C1 minus S and P2 will be C2 minus S. And for k greater than or equal to 3, my Ck is going to be Ck minus Pk minus 2 is going to be Pk. So using those encoded messages, again the same way, I have two letters R and X. So for R and X, I know that the numbers are 17 and 23. So 1 minus 17 is negative 16, which is 10. 1 minus 23 is negative 22, which is 4. So I have these two letters, 10 and 4, for P1 and P2. So K, E are the two letters. Now I have to use the same 10 for getting my C3 and 4 to get my C4. So repeating this process, I get the value for the last one as 10 minus 17 is negative 7, which is mod 26 will be 19. So the answer, the decoded message is keep this secret. So this video helped us to understand the key method for Blaise de Vigenere's cipher method. There are two different approaches. We saw only the keyword method. In the keyword method, that is the seed primer, we used with one key, one letter or two letters. Hope this video was helpful to understand the Blaise de Vigenere cipher, encoding and ciphers. Thank you for listening and thank you for watching. Thank you for your patience.